So we know that in order to use Lambda, we must have a functional interface, and anywhere a functional interface is expected, we can pass a Lambda expression. So in this video, we will talk more about functional interfaces, what are functional interfaces, and how do we write one. So an interface is a functional interface if and only if it has a single abstract method. It can have multiple non-abstract methods or various static and default methods, but as far as an abstract method is concerned, so there must only be one. So here we have an empty package. So let's try to create a functional interface. I'm going to name it calculator, and this is an interface. So here we have the calculator interface. Now, right now, this interface is empty. It doesn't have any method. So it's not a functional interface. It must have a method and a single abstract method. So let's add an abstract method, calculate int x and int y. So we added an abstract method to this interface. The name of the method is calculate with an integer return type, and it will accept two parameters, integer parameters. So this is now a functional interface because there is only one method and it's abstract. And we know that it can have a default method or static method, but it will still be a functional interface because there will only be one abstract method. So if I do add a default method, so we know this is not an abstract method because it has a body, but still the interface is a functional interface because there is only one abstract method, calculate. But as soon as we add another abstract method, let's say do something, then this interface is no longer a functional interface because now there are two abstract methods. So in order to be a functional interface, an interface must have a single abstract method, and if I revert the change, if I delete this new method, then again this is a functional interface. Now there is one more thing on the functional interface, is the functional interface annotation. What does it do? So it's a class level annotation. We add it to the interface. So we say @functional interface. Now this annotation is basically to make sure that if by mistake someone else is adding an abstract method to this interface, the compiler will throw an error. It will be a compile time error because the intent is that this interface must be a functional interface. That means it must only have a single abstract method. So by mistake, if someone adds a new abstract method in the future, it will break the contract of the functional interface because there will be more than one abstract method. So the compiler will check this and it will generate an error. Now let's see this in action. So we tagged the interface with functional interface annotation, and right now there is only a single abstract method, so it's fine. But as soon as, let's say after certain time, someone is making some change in this interface and by mistake he or she added a new abstract method, do something. Now because now there are two abstract methods which breaks the contract for functional interface, so we see a compile time error by the compiler that maybe you are making a mistake. This is supposed to be a functional interface, but you just added another abstract method. So either remove the functional interface annotation and make the changes in other places, or remove this method so that it remains a functional interface. All right. So that's pretty much on the functional interfaces. In the next video, we will try to use this using a Lambda. That's it for now. Thank you.